We note that V2 is such a vertex where 8 unit comes out and that gets distributed to 5 and 3. So, we can call informally V2 vertex as no loss, no gain, nothing is stored here, no deficit happens, and V1 is the one which is losing fluid. So, I can call it informally losing vertex. V4 I can call informally as gaining vertex, V3 is gaining, so I can call it a gaining vertex. Another point, once we look at these sums, only the losing vertex has got a positive amount which is coming up, and all the gaining vertices V3 and V4 has got negative numbers. Conversely, if we look at this vertex V1 and the column sum, only the losing vertex has got a negative number and the gaining vertices V3 and V4 has got positive numbers. So, now let me draw this graph in the next page and pose some interesting questions. So, this was our graph on which we were working and creating the matrix. If I ask you a question, is this possible in nature by some way, or is it possible to have artificially a situation like this? Eight unit comes in, 2 unit goes here and 3 unit goes there. That means there are no loss, no gain vertices, and you can see the total input to V2 is 8 and the total output from V2 is 5. Similarly, if I ask you a question, eight unit goes in, 12 unit goes out and 2 unit here goes out. So, here also this is a case where there is a no loss no gain vertex. The total input to V2 is 8 and the total output from V2 is 14. So, my question is, are these two things possible? You can pause the video, think about a natural or artificial case and then come back. I always hope when I ask you to stop the video, you do that, and now here is the answer. Surprisingly, yes, they are possible. For example, at V2 some storage system is developed. So, what comes in is more and what goes out is less, and here imagine V2 as a heating system. Just giving an example, 8 units of water goes in, gets heated up, and the water that goes out are 12 and 2. So, these are possible. So, graph theory deals with all these three kinds of graphs. So, we can have this case, but these two are also possible. In these two graphs, there will be no loss, no gain vertices. So, if you write down them in the matrix format, V1, V2, etc., V1, V2, etc., by summing up, nowhere you will get 0, and here also by summing up, nowhere you will get 0. We will now see digraph and its matrix, and what if the two vertices are merged. Take this graph G and you see that the matrix has been constructed. I would request you to write the matrix first by your own, then look forward. To learn the subject, we have to do certain basic things. I hope you wrote the matrix, and here you can check. First of all, we do not see any loop in V1, V2, V3, V4, V5 and V6. So, therefore, these elements are all zeros. This diagonal consists of all these 0 elements. Next, we are going to have a skew symmetric or an anti-symmetric matrix. We are going to use the weight of these edges, and that has been done. If you sum up all the elements, you check that the sum is coming out to be 0. For example, these 2 if I add up become 0, 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 and rest are many zeros. Suppose we are going to merge V5 and V6 vertices. How the matrix will change? If this is asked, one easy way is that you can merge V5 and V6 vertex in the graph. You can draw a new graph. Looking at that, you can write down the matrix, but this will not be possible if the number of vertices are very large. Let us say 9566 vertices are there and the matrix is given. Now it is too much time taking to draw such a huge graph. You need not just you may need the ground surface, and then it is a waste of time. So here our aim is to learn the technique based on small number of vertices. We are still dealing with 6 vertices here, and once the thing is learned, then we can apply that for a very large number of vertices. To merge V5 and V6 and how the new matrix will look like, the first job is write the matrix so that V5 and V6 come side by side. To do this, side by side, and we note that in this case it is already there. They are kept side by side, and here they are kept side by side. So what is not being asked, if this is the problem, V5, V6 vertices, if they are not side by side, we can write them side by side. For example, the given matrix is like this: V1, V2, V3, V5, V4, V6, and here V1, V2, V3, V5, V4 and V6. Here we see that V5 and V6 are not side by side. So the operation that I am going to show will not work in this case. It may become difficult. Suppose this is the matrix given to you for that graph. In that case, convert to such a matrix format. That is the first job. The next is, I will draw boxes that will include V5 and V6. Next, since V5 and V6 will be merged, we can call the new vertex as V56. V56 is what? This is a vertex where V5 and 6 have been merged. So the new matrix can be written in this way: V1, V2, V3, V4 and then V56. These two will be merged, and then here V1, V2, V3, V4 and then V56, because these two vertices will be merged. We are going to see how mechanically the work can be done. I will pick up a part of the matrix which is lying outside the two rectangles that I have already drawn. This red rectangle will be inserted over here. Okay. So here this red rectangle involves V1, V2, V3, V4. As you can see, I have drawn the rectangle covering V1, V2, V3, V4. Here it covers V1, V2, V3, V4, and here also I have covered V1, V2, V3, V4. Next step is, whatever is written inside the red rectangle, write as it is within the new matrix. So 0800, it is done. Next, V5 and V6 will be merged. So add them up. 0 plus 0 is equal to 0, 0 plus 0 is equal to 0, 0 plus 0 is equal to 0, 2 and 1 added up will become 3, and I stop. So what has been taken care? We have taken care this part of the matrix by adding up. Next, I will take this, these two will be added up, V5 and V6 being added up, so it is 0. These two will be added up, so it is 0. these two will be added up, so it is 0, minus 2 and minus 1 will be added up, so it is minus 3. So, what has happened? This rectangle has been taken care. We are left with only one space in the new matrix, and that is this box. Here we have to write some number. We can see this box here is actually the intersection of two rectangles, this long one and over another one. This is that rectangle. So, here all the elements are to be added up, and here I have to write 0. All the elements are added up and it becomes 0. So, in this way the new matrix has been constructed. We see that it is again a skew symmetric matrix. Check it out. V2 to V1 is minus 8 and V1 to V2 is plus 8. Here it is minus 5, V3 to V2 and V2 to V3 is 5. V4 to V2 is minus 3 and here V2 to V4 is 3. V56 to V4 is minus 3 and V4 to V56 is plus 3. So, the story matches. Now, it will be obvious, but I want to demonstrate how the new graph will look like. That will be obvious if they merge, but let there be no ambiguity left. Two plus 1 becomes 3, and precisely this 3 can be found within the new matrix. This 3 can be found within the new matrix over here, V4 to V56, and its response is also found in another place as minus 3, V56 to V4. So, in this way the two vertices have been linked. You can also link three vertices. We right now tried V5 and V6. You think about it and you can find out a way to merge V4, V5 and V6. Or suppose you merge all the vertices, what will be that looking like? That means a single vertex with V1, 2, 3, 4, 5, 6. Can you write down its matrix? Think about them. So, the way we have basically linked the two vertices, if required we can also break one vertex into two new vertices. Let us give you an example, and this one you can try by your own. Say this is the graph and some flow numbers are given x, y and z. Now, in a new graph we decide to break V4 into two parts, V41 and V42. So, in this case, how from a matrix, a given matrix you can write down, develop some formula, some mechanical way of writing the new matrix. I would request the students to try. So far we have seen the graph where the weight is a definite number, crisp value. What if we do not know for sure that this number is x, this number is y or this number is z? For example, two to 3, so then this would be basically a range of weight is given. In that case, how to construct the matrix? So, I have drawn a directed graph with weight, but the weights are having some variation. V1 to V2 it can vary from 2 to 3, V2 to V3 can vary from 9 to 4, and from V4 to V2 it can vary from 1 to 5. In this case, in the matrix format of writing, we will use two numbers. Here first we will write the minimum number and then we will write the maximum number. Suppose we define in this way, then the entire matrix can be written. From V1 to V1 no flow happens, so 0, 0. From V1 to V2 it will be 2, 3. I wrote in one place 9 to 4, so it will be basically 4, 9, and when we are dealing with the negative opposite directions, it is -9, -4. Suppose we have this graph G1. In this case, what is the way to merge the vertices V3 and V4 into V34? I am asking the students to devise a way, and it is not very difficult. Remember, when we are dealing with a digraph and putting an arrow in geological case, this can also change sometimes to this. The direction can change. Example is ebb and tide. In case of organisms evolution, this is not possible. From organism A, organism B has got evolved. There is no evidence that from organism B again it will go back to A. What if the two graphs are given and one vertex of one graph is superposed with another vertex of another graph? How the new matrix will look like? Let us try to understand. So, two graphs G1 and G2 are given. I want to write down their matrices M1 and M2. Now, we decide a new graph G will be constructed, which will merge G1 and G2 in what way? That the V2 will be added with V3 and a new vertex will be constructed. Let us call it V23. That means, how the new graph will look like? It will look like this: V1, V23, and then here will go V4 and here will be V5. This is the meaning that the one vertex of this graph G1 will be merged with another vertex of the other graph. And how the matrix will look like? We are posing a question for such a G, how the matrix will look like. Can we devise a process, and then with that we can work with very large number of vertices also. To do this, we utilize the existing vertices of G as V1, V23, because V2 will not be there separately, V3 will not be there separately, then V4 will be there. Look at this graph and you can understand, and V5. And I will write here V1, V23, V4 and V5. Next, write down this matrix over here and write down this matrix over here. Note that when I have drawn the two colored rectangles, there is a superposition given, because V2 will not be there separately, it will become V23. So, also here V3 will not be there. So, that is the reason a superposition is given. Now, let us initiate the process. 0, 1 and 1 can be stated, 0, 1 and 1 can be stated. Next, I skip this one, and here on V3, which is basically going to be V23, I skip. Rest of the things I will write 1, 1, 1, 0, 0, 1, 0, 0 and then 1, 0, 0, 1, 0, 0. Now, the question is what to write in this box. Find out from these two, here it is 0 and here it is 0. So, I will write here a 0. Next, whatever are the empty places in the final matrix, I will fill up with zeros, and by doing this the new matrix M is produced. You can now look at this matrix and compare with the graph, you will find that the thing has gone correctly. Why we put zeros here? Is V4 going to be added with V1? Here is V4, is it going to be added here? No, so it is 0. Is V5 going to be added with V1? The answer is no, so it is 0. For same reason, these are 0. So, whatever goes outside the rectangle, zeros are given, and for these 3 elements we wrote things as it is, because earlier V1 was not making a loop. So, here I will write 0 as it is. V1 is connected to V2, V2 will become V23. So, that will also be connected. So, it is 1. V2 is connected with V1. So, here it also has to be 1, it has to be 0. In this way you can also apply the same logic and you will find these numbers are well represented. Now, the issue came with this number, and we have seen what is common in both I have written down. Now, that is given in the textbooks. What is not given in the textbook, what happens if these two numbers do not match? Then how we are going to put this number over here? Let us give an example. I mean to say, if instead of G1 I am dealing with G1 dash, where here is V1 and here is V2 and V2 makes a loop. So, in this case the new matrix will be slightly different from this. What is that? It will be 0, 1, 1 and 1. Do you see the change? V2 is making a loop. So, instead of 0 here 1 has come. Now, how you will handle? Suppose you are adding up G1 dash and G2 to form a new matrix G. On this V1 and V2 and a loop, you are going to add V4 and V5 and calling it as 23. The loop exists. So, a combination of 1 here and a 0 there will be here given by 1. I am not writing, but I am just telling it will be 1 over here. Here it will be 0 will be replaced by 1. So, I have told you a case of dissimilar, one is 1, another is 0. What happens here? What if here also there was a loop V3? So, what change would have happened in G2? This would have been, instead of 0 would have been 1. So, here is a loop and there is another loop, both the loops will be combined to a single loop and 1 will be coming over here. I am not writing. So, I hope it is understood.